All right, so let's go right ahead and plot the magnitude response for this RL circuit. I've gone ahead again and plugged in the same values here for F and obtained the magnitudes as we vary F from 1 to 10 kilohertz here on the x-axis, right? I'm starting at 1 hertz and I'm going out to 10 kilohertz right here. And the first value is that at a value of 1, I get 0.0063, so a very tiny magnitude, which is basically down here right at around 0. As I go to 10, I get a little bit bigger, but it's still basically at 0. It's going to be 0.0627. Then I move up to 100 hertz, and I'm at 0.532, so right around here. At 300 hertz, I'm up to 0.8834. So now I'm getting pretty high up here. I'm getting close to 1. Oh, that's at 300, sorry, right here. And then at 1,000 or 1 kilohertz, I'm at 0.9875, which is basically 1, right below 1. And then at 10,000, I'm at 0.9999, which is basically exactly equal to 1. And so if I were to draw my frequency response for this RL circuit, basically it's going to look something like this. Oops. Something like this. And of course, again, we have an asymptote right here at 1 because my output can't be bigger than my input. For this circuit, for only passive components, I can't get an output that's larger than my input. Well, in first order circuits, at least that's the case. We'll see later. Maybe we'll see later that you actually can, but we're not going to talk about that right now. This value asymptotes right at 1. If I plug in larger and larger values for the frequency here, I just keep getting values that are closer and closer to 1. So basically this thing tends towards 1 in the y direction as F goes out towards infinity, okay? And so that's the frequency response. That's the magnitude response, I should say, for this circuit. Let's take a look at the phase response. So at 1 hertz, I get a value of 89.64. So I'm all the way up here near 90 degrees, right? At 10 hertz, I'm at 86.4, so just a slightly lower value. And then at 100 hertz, I'm at 57.8, which is kind of somewhere in between these two here. At 300 hertz, I'm down to 27.9, so that's going to be right around here somewhere. At 1,000, I'm at 9 degrees, so I'm just barely above 0 here. And then at 10 kilohertz, I'm at 0.9 degrees, which is basically 1 degree or down there. So this is my phase response for this circuit. It's going to look something like this. And it's going to asymptote at 0. All right, so we drew our magnitude and our phase response for this RL circuit. Let's go ahead. I don't even actually know what I have in the next slide. What do I have here? Oh, okay, so I have the frequency response, but it's looking like my GoodNotes needs to be closed because this certainly is not supposed to be there. I think this happens sometimes, so if I close out my GoodNotes and come back, this will probably be gone. So this will probably be a good place to stop the video, but it is good to note that look at my magnitude response. This is what I drew, and here is my magnitude response from LT Spice. It looks very, very similar, and this is what I drew for the phase response. And in LT Spice, the phase response looks very, very similar. So that's a good place to be. Looks like we did it right. I'm going to go ahead and end this video. This, again, is not supposed to be here. I'll close out GoodNotes because if I try to erase it right now, it's not going to do anything. I've seen this error before. So let's go ahead and end this video, and in the next video, I'll talk intuitively about the RL circuit and what we're seeing in this frequency response for this RL circuit. Okay?